welcome to this presentation at this nice CanJam here in New York. I really like it very much. It's something, yes, very encouraging and nice to be here. So, Sennheiser is known for open-type headphones. Sennheiser is the inventor of the open principle. That was in 1968. You may know this legendary HD414, the black one with the yellow pads. And so I need to tell you a little bit of the history of headphones. It's just a little bit to understand. No, not mine. I don't have the mic with me. No. So headphones started with Alexander Graham Bell with his tuned reeds, so where he could transfer, yes, sounds already. And then in the beginning of the 20th century, you had really something like telephones, where you press something at your ear and talking into something. And that technology, yes, stays there for a long time. These were, yes, moving, so the voice cords were fixed. You had a static magnet field to an iron plate, and this iron plate was, the magnet moved this iron plate a little bit to itself, but in a static way. And the voice cords around the magnet weakens or strengthen this magnet field, and so the diaphragm was moving. And it's a metal plate. With this kind of metal plate, you can't do a lot of movement, of course, and so it's not good for bass response, and the high frequency response of this is depending on the volume in front of this metal plate. So they try to make the volume as small as possible so that the upper cutoff frequency is as high as possible. So you may know the pictures of headphones from World War II, where they had these little round things on their ears pressed very strong to the ears so that the volume is very small, one thing, and that they are airtight, the other thing, because when they are airtight, so the frequency response, and this is the good thing about closed headphones, and they were all closed, of course, is that when it's completely closed, and closed headphone is really flat until 0 hertz, because what you have is a pressure chamber, so a small chamber with air in, and the diaphragm just behaves like a piston, compressing and decompressing this air. And that breaks down to 0. So really a flat line. So the advantage of, no, I need to continue with this. And that biodynamic in 90-something, 37 I think, they developed this dynamic drivers. That was a step forward. They sounded better, but they still use the same principles, small volume, but not a moving metal plate with a lot of distortion, but already a voice coil, a magnet system, and the voice coil moving a diaphragm. So that was much better. One of these headphones is still, oh no, they stopped production, I think 3 or 4 years ago, the DT37. So that was a long production time. In the end, it was just used as a headphone for audiology. I think it just, yeah, do you know more? Just audiology, right? Yeah, in the end, yeah. Yeah. DT48, no, not 37. 37 was a year, but yeah, 48. Sorry. And when Sennheiser developed this open-type headphone, that was state-of-the-art, more or less. There were some stacks, things already from the 60s, electrostatics, that sounded very well, but they were closed as well. Corset, too, electrostatics. And with the open principle, you don't have to have a very close volume in front of you, and the sound that is radiated to the rear from the diaphragm can just leave the system. The sound that is radiated to the front can leave the system as well. And so in total you don't have the resonances that occur when you have a closed type. And everybody can hear what happens when you have a closed type. So when you just take your hands like that and put it around your ears, you can hear that resonance that occur in a cavity. It's the same as when you have a shell at the sea and listen to it. Some people say that you can hear the noise of, or the sound of the sea. It's not the sound of the sea, it's just the airflow, and it is amplified by this resonance. So the advantages of the closed types are, of course, good sound insulation. So a closed type is closed to the ambience and you don't hear the sounds from outside. And yeah, your family or whoever's around can't hear what you're listening to, more or less. Depends on the sound insulation and how, yes, rugged the structure is built. And as I said, very good low frequency response because you have a pressure chamber when it's airtight. Normally headphones are not really airtight because you have an ear pad, you have a very individual structure here, so you have hair, you have frames of glasses, and they form tubes, and you have leakage there, and the leakage leads to, and now a flip chart would be good as well, leakage leads not only to low frequency, where are the lows? Low frequency loss, but you have a cavity and you have a tube, and the cavity and the tube, this is a circuit that brings a strong resonance, so you have a resonance frequency of that. And this is audible as well when this is not damped. Okay, so resonances are the disadvantages of the closed ones. So because acoustical energy could not leave the housing, so it is in and needs to be absorbed somehow. It is bounce force and back in the housing in normal headphones, and or it goes through the diaphragm and forms patterns in the frequency response. And as I said, the air tightness has a massive effect on the low frequency response, because when it's not airtight, it goes down. And of course, on a closed one, you get sweaty ears. I don't really have a very good solution for that. Maybe we can include a fan like Audio Precision is doing that for their audio measurement systems. Okay. So the target for the acoustical development of the HDA20 was quite simple. Create a closed type headphone that keeps the advantage of the closed principle and avoids the disadvantages. So something that is sound insulating and has a very good low frequency response, but avoids the resonances and sounds as good and open as open type. Okay, simple. So let's see. Our solution for that is, yes, an open headphone like the HD800, and when you're in a room like that, here, okay, you have a volume around you, and now shrink this, and then we are where we are with a HDA20. So very small living rooms on both sides. Still have the problem. So this is something against the low frequency thing, because we still have this parallel airflow from the front side of the diaphragm to the rear side. So when you have some additional openings here through the frames or so, it won't affect the frequency response that much, because you have already parallel to that an airflow, and so this additional opening is not that much affecting the frequency response than it has been without this. So you don't have this resonance and you don't have this massive fall down. So this is a sectional view of the ear cup of the HD820. And what you see, it's not everything shown. It's only something how to illustrate how it works. So what we have here is the ring radiator diaphragm, very well known from the HD800, and it's exactly the same. It's exactly the same part that we use in the HD800S. So in the middle we have the Helmholtz absorber that we have brought to the HD800S. So this is the difference between HD800 and HD800S. And this 40 millimeter pure aluminum voice coil. So this is exact. So you can't see the voice coil. We haven't drawn that. And so our industrial designer, we make many different trials how to show that. It radiates sound, of course, to your ears, and this is what happens in every headphone, and it radiates sound to the rear as well, and that happens in every dynamic driver is doing that as well. And but it is not open, so it could not leave the system. When you have something that is curved like this, all the energy would be focused to the center and reflected back. So you have an effect like what you're doing when you put your hands around your ears. So you have really a strong resonance. When you just use a plate, that's better. We tried that, so we have different shapes. We made them in the beginning, of course, out of plastic with a 3D printer. Today, prototypes with 3D printers are that easy. So, okay. And when you have a shape like that, the acoustical energy is reflected. It's not like that. It's more like this goes into these chambers. So these chambers are made to absorb the high frequency energy, and in the bottom of these chambers is stainless steel mesh that makes the connection between the front volume and the rear volume. So this is for the low frequencies, and yeah, so this is the whole thing, the whole principle of it. And yes, it works. So, so when we've shown that in Las Vegas, and from time to time I have the time to read a little bit in HeadFi, and especially when I have new products out, it's very interesting for me to see how the reactions are. A lot of questions came there, and some people don't really like the solution. I don't know why, but they ask why do we use curved Gorilla Glass. This curved Gorilla Glass is especially made for this product. No one did that in that way before. It's a German company buying flat Gorilla Glass from Corning, and they deep draw that for these headphones. Took a long time until it works, but now it works. So Gorilla Glass is very lightweight. So we want to make a headphone that is as lightweight as possible for longer listening experience. So so my idea is not that you should listen to headphones. My idea is that you should listen to music. And everything that is annoying or gives you the feeling something is pressing or hurting me or so, gets you away from the music. And so it should be as comfortable as possible, as light as possible, and as good sounding as possible. So this is the idea behind it. And so we made it as light as possible. And you can try it. I have one here. It is not that very heavy. You can wear it for some hours. I need to do that in my job. I need to listen to music, unfortunately. No, sometimes it's hard. But yeah. And this Gorilla Glass is lightweight and stiff. So this is the benefit of it. So these plastic things that we made in the beginning for trials, this 3D printout, there was ABS, was not stiff enough. It starts swinging and we need to bring in ribs for our trials. So the Gorilla Glass is stiff enough. You don't have resonances, and the rim is damped as well, so that when resonances occur, they are dampened. So yes, it is curved to spread the acoustical energy. I have shown you that. And one very important thing is we found no supplier for this transparent aluminum. So we want to show our transducer because it is a very good transducer, a nice transducer. This is what I think, okay. But I think it's still the best dynamic transducer on this planet. Some other companies will disagree, but maybe in this case you should measure them and compare. And listen to them, of course, as well. So now we have the board, and I want to draw a little bit, and for this I changed the hand. So frequency response-wise, no. Yeah, so we have amplitude here, frequency here. Say, okay, we start here somewhere at 20 hertz, here's 100, and more or less in the middle 1K, and somewhere here 10, 20. So in the high frequency range, from here on, a closed and open are more or less the same. They're not big differences, not by principle. And so when you want to have differences, you do that in the shape of the thing in front of the transducer, with the transducer itself, and yes, that's it. So say, okay, we have here somewhere something frequency response like this. It's always a little bit when you measure it, not really flat. So when you measure it in the free field, so without a coupler in front of it, just with a microphone in front of it, you don't have these reflections, then it's more flat. And in the low frequencies, so maybe, yeah, no, it's okay like that. And the low frequencies, open one looks more like this. Then it should go down. This is, yes, important to have a little bit more here than here. And yes, you get a curve like that for the HD 800. And I can tell you why it looks a little bit like that. So at 1K, you have less than 100. And the reason for that is when you listen to loudspeakers, and the most music, and we had some nice lecture here yesterday where this room feel thing was explained. And yes, we have very similar experience, but from other measurements, when we compare probe mic measurements in the diffuse field and subjective, not measurements, but people are listening to the sound field, we have always a discrepancy of 4 to 5 dBs compared from 1 kilohertz to 100 hertz. So the microphone says it's flat, maybe, and the test person say, no, we are missing 4 or 5 dB. And this, the reason, when we listen to with headphones, and the reason for that is you don't have the body channel. So the anchor tones or the anchor noise is radiated by loudspeakers, and you compare the loudspeaker sound with the headphones, and you found this discrepancy. So you need to compensate that, and to make it sound linear, you need to have a little bit more here. And of course, the open headphone is open, and this is the region where you have the resonance frequency of the transducer itself, and below the resonance frequency it goes down. Okay, some people think, oh, we need lower resonance frequencies. We're working on that. So for the closed type, let's see if I can use the red one for that. You need to compensate a little bit for this losses with frames, because it's not that open, the opening inside, as an open headphone. So when you have a frame of glasses with an open HD800, you won't see that. You can try it on a coupler, just put a screwdriver under the, we did it several times, and you won't see the effect. When you have a real closed one, you have really a massive effect. And to compensate that, a closed one should have a little bit more. A classical closed one looks more really, oh, no, yes. Really like that. Our closed one is not a closed one, but a closed open one, so it has a little bit like that as well, not that much. And then it goes down. And in the lecture yesterday, or no, I think it was in the panel discussion, said, okay, everything gets a little bit clearer when we don't have so much at 160 to 200 hertz, and this is a very well-known effect. So it's a little bit like this. No, it's too much, like that. And then it goes into that curve. So we take a little bit out here. By design, we could change that but with a damper, but we are convinced that it sounds better this way. The prototype you're listening to here is not, the slope is not at the right position. It is a little bit too much here. And so forgive me, it is not perfect. It's at 95% or so. The sample that I have now on my desk is here. And when we are in production, it will be there as well. We have a little bit, due to the cavities, and yes, we have these absorber chambers, but there's still the energy not out of the system completely. We have here a little bit more than we have it with the HD800, but all the rest is the same. So I think, and yes, I'm critical, especially with myself and what I'm doing. It is okay. It's so target is accomplished. So we did it. It is a nice headphone. We are not at the end with it. It will be available in summer, and then we will be at the 100% that I have in my head. And yeah, I think in early summer it will be on the market. And it was worth the work. So I started with that, I said it already, in 2012. And we were really working on that. So one approach, a different approach. So the first idea was really to cover the HD800 with a cover and leave everything inside, but the whole thing is getting too heavy and too bulky. So the headphone should not be too ugly. So okay, I read the comments when the HD800 came to the market, where one guy wrote, the best thing about the HD800 is when I have it on my head, I don't have to see it. But I think today it's a kind of icon, and of course when you look at the industrial design of the HD820, we try to keep as much of the HD800 as possible in this closed design. And you see, what you see here are the pixels. There will be a structure on this surface as well, and the same structure on the inner part of it to have the surface even bigger for absorption inside. Okay, thank you very much. So I think I'm too fast, right? I have no idea how late it is. Let me have a look. Oh, just half an hour. That first. So we have a lot of time for questions. I can think. And how much did you pay for just that drawing?
It was a fortune. But no, I don't think they charge us for it. But the curve that you're showing for the 820 has a pretty steep. Remember, it looks kind of like the one that the preference curve from Harman.
Yes.
Is that a similar sort of slope that you're showing?
It's very similar.
So is this why you were
but we.
I said it would be
Yeah. So.
challenging to do?
So. It is not that. So I didn't say it was chilling. When you look at or listen to things like HD 280, it is not that different, not so much different in the low frequency range. It is different in the mids, unfortunately, because we didn't make this thing with a concave plate there. We didn't make that with the absorber chambers. But the low frequency was very similar already, and that was 1999, I think, when I made that. So yeah, so I think this is absolutely right, what they found out. I found that out earlier, but yes. But just by listening and measuring things, I think this is not bad to trust your own ears. And yeah, so yes, it's the same effect, yeah. And it's definitely good to have a little bit less here. So it could even be a little bit more. So we can adjust that just with dampers. This is not finished yet as well. But when you look at some other headphones, it is at too high frequencies, and this is when you listen to this, it is a little bit more too much of this, and it should not. So it should be like clear voice, because of course enough of bass, yes, but not this thing, and you can avoid it by just having the slope at the right position. Okay, more questions? Yes, please.
Can I describe the 820 as semi-open or semi-closed?
No, these things are defined, and which is which. So when you have a closed ear pad, so the front side is closed and it's open to the rear. It's semi-open. There are some headphones, some Sennheisers as well in the market, which follow that principle. You got a good bass response and things like that from that, but and this sound, the acoustical energy goes out of the system. That's nice, but it's not closed. You can still listen to your environment, and they can listen what you're hearing. And the opposite thing is, I don't remember a headphone which is where the cup is closed and the ear pad is open. The only benefit of that is you don't get the sweaty ears, but the sound goes out. No. So Sony, with the MDR Z1R, they do something smart. It is not fully closed at the rear. It is, there's an acoustical impedance. So when you have just a closed wall where no sound can go through, okay, you have the reflection, no sound goes through it, only when it resonates. When you have materials like thin paper that is used as filters or so, you have an airflow through that. So the filters in vacuum cleaners, for example, this is a very similar material. as that was used for headphones for many years. The disadvantage of the paper is that it has high tolerances, and we try to make our headphones, especially in that price range, one like the other. And therefore we use this stainless steel mesh because we have, oops, when I go back to, yes, this is a nice picture. I like it very much. Listen to it, it is over there. But now back to the point where I really want, to this picture. So we have, of course, damping material in here as well. It's not only the one shown in red here, but we have the dampers for the fundamental frequency of the transducer made out of stainless steel mesh in there as well, because the tolerances of these materials are very, very small. And so this is good for us because we don't have so much, when you have limit files in your measurements and say, okay, everything that exceeds the limits goes to the bin. That is very expensive when you use more expensive material and keep the limits. You don't have to throw so much in the bin. So this is good for us, good for the guys who are doing this stainless steel mesh, and it's good for you as well, because when you buy an HD800S today, and you buy the next one in 3 years, it's the same. So, and we do measurements of each and every transducer first. We match them, so there are stickers on these transducers, and say, okay, this is number 589, this is number whatever, and they match the best. So computer program looks through all these measured data and match them as good as possible. And you just found that this matching seems to be better than I expected it to be. Yeah, and so this is the thing with the measurements. Okay.
Just to ask real quick, so on the exterior of the HD820, it still looks like there's mesh, but you said earlier that that's purely cosmetic to harken back to the HD800. It just has that same sections, but they're completely closed.
Yeah, they are completely closed. Ah, yes, I started with the Sony. Yes, I didn't finish that, so I go into that. Thank you very much. Yes, the Sony, there is a sound passing through that, but not in very high level. So I think this is a good idea to do that. In that way, we have a different approach. So, yeah, compare these headphones, and I think that's a good reason to use closed ones. So someone asked me at a booth, which is the better headphone? Does the HD820 sound better than an HD800S? I could not really answer that question. So yes, an HD820 has more bass, so I think maybe it's a little bit more right in the bass frequency range. An HD800 is a little bit better here. It has more room. So HD820 is the headphone with the widest and yes, soundstage that I know. Closed headphone with the widest soundstage that I know. But an HD800 by principle has a better soundstage. So you have to make your own choice. So it depends on the use case. So when you have the space and room to listen to an open one, an open is good. When you want to have it more universal, listen to it at the office or wherever, an HD820 is the better choice.
Did you first conceive of the small room concept and then realize that you could make a really great closed headphone? Or did something inspire you that I really need to make a flagship closed headphone that is as good as possible and better than anything we've done before?
So I always wanted to make a closed one that sounds as good as possible, and try to find ways to do that. And yeah, as I said, so I think it's not that bad at the moment. So, you know, I'm in the headphone business since 1991, and it's always this, yes, we in Germany try to improve things, make it better, make it better. So when you have done one headphone, you know what you can do better. So let's see. Yes. So when we finished the AG1, I had some ideas, but maybe in 25 years. So let's see. So more questions, please.
What are the circles around the back and the inside bezel?
Which? Which?
Like on the inside, underneath the glass, toward the back.
These ones?
No. Straight back, perpendicular to that.
That one?
Back wall.
This is the voice coil.
No.
Nope.
This.
Yes. These are the bass tubes.
Oh. You said that with excitement. Bass tubes.
Yes. So to give this boost here, you need to have small openings to the outside. They are just working in the low frequency range, so no sound can pass through from the outside above this frequency, and no sound can go outside above that frequency as well. So this is a acoustical filter, but in the low frequency range. From here on, it is open. Otherwise, you need a much larger volume to achieve that. It is, from the insulation point of view, not critical, because in that frequency range, the whole headphone is already moved by the sound pressure.
Like low frequency waves can pass through walls and everything already.
Yes. Yeah. So these are the bass tubes, and bass tubes are, this is why I said it with enthusiasm, very important. So a lot of the tuning here takes place with the bass tubes, and the dampening of the bass tubes. They are working to, yes, they are not visible. They're visible from here when you want to have a look at them. You can see them. They are working on this chamber, and this chamber is not completely open, so this has some dampening function as well. Lumped elements. Yeah.
So that's on that side where the cable is?
Yes, they go to that cable connection.
And so is that different part than a second volume? Is it open to that volume?
Yeah, it is not really a volume. It is more a pass-through section, but with a resistance. It should not behave like an inductivity so much, but just like a resistance, and this is what it does.
And it took you about 5 or 6 years to develop this headphone?
So I think intense development work was when you just put everything together 4 years, yes.
Yeah. Cool.
Yeah, but this is okay. I think this is okay. So because I think HD800 came to the market in 2009, it will remain as HD800S, which is an improvement for many years. And when you start something like that, it's good to invest some brain power, some money, and to do something that is a standard for many years. So it is, yes, it is not just changing the color or the shape. So it's really something, yeah, different. So it's not a style or a headphone or something like that. It is, yes, something for listening to music, and I think, so when you, for example, 600, 650s are in the market since, so the 600 for 20 years, over 20 years now. You can still buy it, you can listen to it, it's still a nice headphone. So, and I think this will happen to this one as well.
And compared to the 800, not only is it enclosed, but just to kind of sum it up, you have the curved Gorilla Glass, you have these bass tubes, you have these acoustical absorbers. There's a parts that went into it than simply just closing an HD800.
Yeah, just closing, try that. Try that. This is what I tried first as well. I was young and naive and, yeah, okay. So, and it comes with, of course, 3, so in the moment I have just 3 cables. So it's very universal, so you can connect it to your standard equipment with a 6.3 millimeter connector. As you may know, I like the Pentagon connection very much because it is, I hope it will be a standard. It is, yes, a standard, but in the market for the customers, because when this is a standard, you can use every device and just plug it in a balanced way. I think it's nothing where we make more money with. The XLR4 is cheaper than this one. So these plugs and sockets are very expensive, but they are very good as well. So the modulation of the resistance when it's trembling or when you just move it is nearly not measurable because you have 2 springs pressing to the connector, and the force of when the force of one is lower, the force to the other spring is higher, and so in total it gives a very good effect. So I think use this cable. This is the right cable. It comes with the XLR4 as well for those who have an amplifier with a XLR4 output. But yeah. Okay. So I think
Get you to your plane on time.
yes, I need to catch my plane, but there's enough time for questions still. But when you don't have more questions, I think you should just listen to it. I think, but have in mind, this one will be improved. Thank you.